All right, so in question 1, I ask you to find the limit. So for a question like this, you need to simplify this on the side first before taking the limit, okay? So to do that, whenever you have the square root, you want to multiply by the conjugate. And remember, the conjugate is exactly the same thing as this part. The only difference is you multiply by the opposite sign, okay? So you're gonna multiply this by radical x plus h plus radical x. And then on the bottom is the exact same thing, okay? And then if you distribute, the whole point of doing this is that the radicals will cancel. So you will end up with x plus h on the top and then minus x. So you have to distribute 4 times and you'll end up with that. Also remember that the square root of x plus h, if you square, you end up with just x plus h. So that's how we get that. And then on the bottom, you still have the h, and then you have the x plus h plus radical x. Here, notice that the x cancel, and you can also cancel the h, but just do one more step. It's going to be h over h times this, okay? And then cancel this part. So essentially, this is the exact same thing now as finding the limit as h goes to 0 of whatever you have left, which is this. And then if you plug in h equals to 0, notice that this and this are exactly the same. So you'll end up with 1 over radical x plus radical x, which will give you 1 over 2 radical x. And that's it. All right, so now let's move to number 2. So this requires factoring. So you're going to factor x squared minus 27. And then on the bottom, you have x squared minus 9. So the factor of the top, this will be, this is a difference of cubes. So this is x minus 3 times x squared plus 3x plus 9. And on the bottom is a difference of squares, which is x minus 3 times x plus 3. Now, I expect you to know this formula, but not the cubes. So if it's a cubes, I will give you the formula, which is this. So you have like a cube minus b cube. The factoring formula is this. And if I ask you something with the cubes, I will just give you the formula. But if it is a difference of squares, which is this, then you need to know how to factor that. All right, so then what can you cancel here? The x minus 3. And remember, notice we had to do the factoring because if you plug in 3 directly here, you end up with 0 here and 0 here. That's why you had to do this. Also, a very common mistake people do is this, that they don't write the limit again. If you don't write the limit again, it's technically wrong, okay? So from here, you say, well, this is equals to the limit as x goes to 3 or whatever you have left. Just rewrite it again. And then you plug in technically 3 in here. So you plug in 3. On the bottom, this will give you, 6. And on the top, so on the top you get 27. There's no need to simplify anything. This is just good enough. It's asking to find the derivative using the definition. So here I'm telling you literally what I want you to do. So you cannot use the fast way. I mean, you can to check the answer, and you should to check it. But here, remember that I call this part delta. And I told you that if you have a fraction, what you should do is rewrite delta as this, 1 over h times f of x plus h minus f of x. And then do it this way instead. So first find this part, and then just divide whatever you get by h. And you should only do that when you have a fraction, okay? So then this will be 1 over h, and then if you do this part, this is going to be 1 over x plus h minus 1 over x. And then you should find the LCD. And remember the LCD in this particular case, it was x times x plus h. So therefore the 1 over 1 plus h is missing just x from the LCD. And the minus 1 over x is missing the x plus h over x plus h, okay? Then just leave the 1 over h alone until the very end. So here you have 1 over h, and here the LCD, remember, was x times x plus h, or x plus h times x. And then the first part, this just gives you x, and then this part, you make sure that you distribute a minus sign. So this part is going to give you minus x and then minus h. So it's very important that you distribute a minus sign. So these two cancel, and now you can cancel this with this since you have it outside. And notice this will give you minus 1 over x times x plus h. And then do not forget the limit. So therefore here, I told you when you have these questions, so just pretend that you do the g of x first. So assume that g of x is just 1 over x, okay? So therefore, you take the limit in this function, the limit as h goes to 0 of g of x plus h minus g of x over h is the same thing as the limit as h goes to 0 of this. And the only place where we have an h is here. So then if you do x times x, that will give you x squared. So it will be minus 1 over x squared. Now, this is the derivative of 1 over x, but you want 2 over x. So in this case, this is actually pretty simple. From here, f prime is going to be 2 times this, which will be minus 2 over x squared. And therefore, this is the solution. Now, there's nothing that can stop you from checking with the easy way. Remember the easy way, which you need to know how to do it anyways. F of x is equals to 2 times x to the minus 1. So you do it the fast way using the power rule. This will be minus 2x to the negative 2. And remember that this and these are the exact same thing. All right, so for this question, again, focus on the x squared part only, which is this. So therefore, just call g of x x squared. And find the derivative for g first. And remember, g prime is going to be the limit as h goes to 0 of g of x plus h minus g of x over h. Okay, the exact same formula from before. So therefore, in this case, this is going to be the limit as h goes to 0. Remember, this part is going to be x plus h squared. This is x squared, the whole thing over h. And then this is the same thing as the limit as h goes to 0. If you expand this one, or we have done this now many times, this is equals to x squared plus 2xh plus h squared. And then you are subtracting the x squared. So again, this part is this. So the green parts are the same. Divided by h, notice that this will cancel. And if you divide by h, you will end up with this. This will be 2xh over h plus h squared over h. And this is the same thing as the limit as h goes to 0 of 2x plus h, which is just equals to 2x. And again, we have done this many times. So then the derivative from here then, f prime, is going to be just minus 4 times 2x plus, and then for the derivative of 2x, you can just do the easy way. That will be 2 times 1. So therefore, this is minus ax plus 2. And that's the derivative. That's it. So in this particular problem, essentially what this means is the following. Look, you have like a building that is 80 feet tall, and then you launch a rocket, and eventually has to come down to the ground. Okay? So this, the trajectory is modeled by this equation. Okay? So this is the position. So this represents a position. And it says find an expression for the rocket's velocity. Okay? The velocity is essentially just the derivative. Okay, so derivative. Oops, that's not how you. Let me write down. So velocity is the derivative. Okay. So therefore, how much is h prime? Well, remember this multiplies this, so that should give you what? Minus 32t plus, what happens to this part? You end up with just what? 64. And the derivative of 80 is 0. Why? Because 80 is a constant. Okay? So therefore, this tells you the velocity of any time, okay? From 0, which is here, until it hits the ground. So then, and we're going to do this in more detail later. So what do you think is the velocity when you get to the maximum point? Like here. What is the velocity there? So if this goes up, right? It goes up. It has to get to a point where it technically stops. And then what? It goes down. So the maximum high means that the velocity has to be what? 0. Okay? So the maximum altitude, this means h prime has to be 0. And all you have to do is solve this equals to 0. And this is a very simple equation to solve. This is equals to minus 64, which means t is 64 over 32, because both of them are negative, and this is 2. So essentially, it takes 2 seconds to get to the maximum high. That's all it means. And it actually takes like 5 seconds to hit the ground. Okay, so you can see the word problem is pretty simple. All you do is take the derivative, and sometimes they just ask you to plug the value here. If they ask you for the maximum altitude, all you have to do is set the derivative equals to 0. There is a whole chapter on this later. I think it's chapter 4 or 5. But for now, you find the derivative, set it equals to 0, and find the value. That's it. Okay? Now, question number 4 is also very, very simple. They give you the function already here. And this represents the percentage of family that were married couples with children between 1970 and 2010. And here T1 corresponds to 1970, and T is measured in 10 years, so every 10 years. So therefore, T equals to 1 is 1970, so T equals to 2 is what? 1980, and so forth, okay? But notice, since we're going to take derivatives, it's much better to write P of T as just 50 T to the negative 0.25, okay? We haven't done anything with decimals, so you don't like the decimals, change to fractions. Notice that this is exactly the same thing as 50 T to the minus 1/4. And we have done derivatives with this before, because 0.25 and 1/4 is the same thing. All right? So now part A is now the derivative, because it's just asking you straight out, what percent of families were married couples with children in 1970? So therefore, what do you think you have to do here? If it is 1970, so 1970 it means what? T is equals to 1, right? So this is there is no calculus in this question, okay? So this is just pure algebra, okay? So all you have to do is plug in 1. So this will be 50 divided by 1 to the 0.25. Remember, 1 to any power is what? 1. So this is just 50 over 1, which is what? 50. So that means 50% of married couples in 1970 have kids. This data, I think, comes from MIT. But don't quote me on that. So this is supposed to be like close to real data. Now, the derivative is going to happen on the next problem. So this one is just asking you to plug in the value. So what about if I go to ask you for, say, 1980? What will be the difference if I ask you for 1980? What is it? Question where you're going to need calculus. So remember what P of T was? P of T was equals to what? What did I say? 50T to the minus 1/4, right? And it says, how fast was the percentage of families that were married couples with children changing in 2000? So it's asking you the derivative at the year 2000, okay? So therefore, here, first you need to find the derivative. That one should be easy. What's the derivative for this? It should be 50 times minus 1/4, or minus 1/4 times 50, and then t to the negative 5/4. Remember that minus 1/4 minus 1 is negative 5/4, since you check on that. So that's the derivative, okay? So therefore, another way to write this is to say, well, this is minus 50 over 4, t to the negative 5/4. So that's the derivative, okay? The year 2000 represents t equals to 4, okay? So therefore, technically the question is, what is p prime evaluated at 4? And then this will be minus 50 over 4, and then this will be 4 to the negative 5/4. And then for this you need a calculator. Then question number 5 is the product rule. And remember that the product rule, so let me do this question in slow motion. So the product rule, this is how you apply it. So it's the derivative of the first one, so I'm going to even write it out, times the second one, plus the derivative of the second one times the first one, right? All right, so the derivative of the first one is going to be 3x squared minus 1, so that's the derivative of the first one, times the second one, plus the derivative of the second one is this, times the first one. And for the test, for this time, there's no need to simplify more. If you get this far, this is good enough. You get there, okay? Yes. All right, so let's go to the next problem. And this is an example where you have 3 functions. So the f and g can be a little confusing here, okay? So this is the perfect example of that. So here you have 2 functions, and this will be the first one, and this is the second one, okay? So for this problem, you have to apply the chain rule twice, okay? So here h prime, not the chain rule, the product rule twice. So I'm gonna rewrite the whole thing. So it's the derivative of the first one times the second one plus the derivative of the second one, sorry, the derivative of the second one which is this, times the first one, which is now this. Okay. Now here you have to be very careful because you have to apply the chain rule again here. Okay. So when you do the derivative of that, what's the derivative of this part in yellow? I guess that's the color, yellow. So you have to use the chain rule again there. So the derivative, the first one is 3. So the first one is 3 times the second one in here, okay? Plus the derivative of the second one, which is 4x squared, 4x times the first one, which is 3x. So the derivative of this one, okay, it gives you all of this. So that's the derivative of the first one using the chain rule again. Or the product rule, sorry. Times the second one, which is x cubed. And let me see. X cubed plus 5x plus what the derivative of this one is going to be 3x squared plus 5. So that's the derivative of this one. Gives you this. I'm missing a prime here. You should have a prime here, just like you have a prime there. And then this one, just leave it alone. As you can see, this can be very, very annoying to simplify. That's why you don't have to simplify. Just leave it like that, and that's good. So again, this is the derivative of the first one times the second one plus the derivative of the second one times the first one. And here, since this is a product, you have to use the product rule twice. So here, this gives you this. What about the next one? This is a quotient, so you have to use the quotient rule, okay? So according to the quotient rule, h prime is the derivative of the top times the bottom minus the derivative of the bottom times the top. Okay? And again, I will give you these formulas. Divided by the bottom square. Okay? Now, what's the derivative of the top, which is this one? Well, the derivative of that is just 2x. Oh, I copied that wrong. It should be x squared. So that's 2x times the bottom, which is this. So remember, this gives you this much. And then minus the derivative of the bottom. Well, the derivative of the bottom is 14x plus 1. So again, the derivative of this one gives you this times the top, which was this, and then everything is divided by this. Okay. And again, there's no need to simplify for now. In the next chapters, you're going to have to simplify, but it's not going to be this messy. So question 6, it requires a chain rule. So from here, h of x, it will be equals to this. Since you're taking the derivative, remember that this is equivalent to this. The square root of x is equals to 1/2. So first we'll write it like that. Then h prime is going to be 1/2 x cubed plus 4x plus 2 to the minus 1/2 times the derivative of the inside. And the derivative of the inside, well, this is the inside. What's the derivative of that? That's equals to 3x squared plus 4. And for now, this is good enough. That's the chain rule. All right, so now for this question, part B, this one requires the product rule because it's a product, but it also requires the chain rule, okay? So first, let's apply the product rule. So according to the product rule, h prime is going to be the derivative of the first one. So let me write it. Times the second one plus the derivative of the second one, and this is the part that's going to require the chain rule at this point. So this one is going to require the chain rule times the first one. Up to this point, this is the product rule, okay? So it's the derivative of the first one times the second one plus the derivative of the second one times the first one, but the derivative of the second one is going to require the chain rule. And sometimes you need the chain rule both times. Now, the derivative of the first part is 4x cubed. So then this gives you this, okay? And then times the second one, which is just x squared minus 5 to the a, plus, and the derivative of the second one, so that's the one that's going to go here. The derivative of the second one, well, this is going to be a x squared minus 5 to the 7, because remember the derivative of x to the a is a x to the 7 times the derivative of the inside, and the derivative of the inside is 2x minus 0, so it should be 2x times, all of this is times x to the 4. So this gives you this much. And again, there is no need to simplify. Okay, so far so good. And then finally, number 7, it's asking to find the n derivative. And we did a problem like this already. We're going to do this multiple times. But remember that this is the same thing as x to the negative 3. And I told you in order to find the pattern, you do not want to simplify, okay? So this will be minus 3x to the negative 4. That's the first derivative. The second derivative is going to be minus 3 times minus 4 times x to the negative 5. The third derivative is going to be minus 3, minus 4, minus 5, and then x to the negative 6. So you keep taking one off. And then the fourth derivative, you should take at least 4 derivatives for you to see the pattern. So minus 5, minus 6, and it will be x to the negative 7. Okay? So the question is, what will the n derivative be? Okay? Now the first thing you should notice, and this is going to be the case for these problems all the time, this changes from negative to positive to negative to positive. You just keep changing from negative to positive. To take care of that, you just do minus 1 to the n power, okay? So this will take care of the changing from negative to positive and backwards all the time. Okay? And then also notice how all of them start with 3, and then it goes to 4, then it goes to 5, and so forth. So the pattern is the following. This is going to be 3, 4, 5, 6, and then if it keeps going, this is where you had to use the pattern. So notice that if the first derivative is a 1, this one stops in 3. So this is 2 more than this. 4 is 2 more than 2. 5 is 2 more than 3. So this is always going to be 2 more than whatever this value is. So if this is n, then this is going to be n plus 2. And then the power, notice that this is 3 more than this, 3 more than this, 3 more than this, 3 more than this. So therefore this is always going to be n plus 3. And that's it. So therefore this is the formula.